Bismillahirrahmanirrahim. Good morning, students. I welcome you all to lecture number 8 of the course of Basic Electronics. In this class, we are going to study operational amplifiers. These are a type of amplifiers which have the ability to amplify the signal. Now, what properties or what characteristics this amplifier have, we will be studying one by one in detail. First of all, we should see that this is a high gain differential amplifier having high input impedance and low output impedance. This is a differential amplifier. By the word differential, before we see the word differential, let us look at the input terminals of the operational amplifier. Usually for any circuit we have one input and one output. However, in case of an operational amplifier, we have two inputs available. One is input terminal number 1, which is the positive input. Other is the input terminal number 2, which is the negative input terminal. We have one output terminal usually for operational amplifier. Differential amplifier actually means that this amplifier will be amplifying the difference between these two input terminals. What does that mean? I will be elaborating it in upcoming slides. For this time, we should only know that this has a high input impedance. The resistance between these two terminals internally is very high, and the output impedance is low. It means the output resistance at this terminal will be very low. This point we have already discussed. Now we will be studying the operational amplifier's properties in more detail. We can see that the operational amplifier has high input impedance. If any device has high input impedance, and if it is an ideal device, what will be the highest value of that high input impedance? Of course, that high value would be infinite. So if we are considering the operational amplifier as an ideal device, the highest input impedance it will be having will be infinity. However, we know that in reality no ideal device exists and we cannot reach any value like infinity. Therefore, we would say that a practical operational amplifier will be having a very high value of input impedance, but it will not be infinity. Okay. Similarly, in case of the output impedance, it is the case that the output impedance of the op-amp is very low. Now, how much low it can be for an ideal device? For an ideal device, this resistance will be as low as 0 ohms. Again, ideal thing does not exist. Therefore, we would say that practically the output impedance of operational amplifier will be very low, but not 0. Similarly, we should know that the gain of operational amplifier is very high. It is infinite ideally, and of course, since it cannot exist in real world, therefore we would say that practically operational amplifiers have very high gains but not infinity. One thing is, operational amplifiers are usually considered as noise immune circuits. Noise immune in very simple term means that they do not get affected with the unwanted signal which are caught by the circuit in any scenario. By noise, we do not mean any noisy voice signals. No, it actually means any other signal which is other than my actual signal will be considered as noise for my circuit. So if I'm saying that operational amplifier is a noise immune circuit, it simply means that it remains affected by the unwanted signals present around. How does this happen? We will see it in upcoming slides. Let us see few uses of operational amplifiers, that where they are used or what are their applications. First, most simple application of operational amplifier is that they can provide us amplitude and polarity changes. What do we mean by amplitude? Please look at this diagram. Here I have a small sine wave and I can now see a large or an amplified sine wave. If I will give this small signal to any operational amplifier, it can enlarge that AC signal into a large AC signal or a large sine wave. This means that the operational amplifier is increasing the amplitude change. It is increasing the amplitude of the input waveform. Of course, the type of the waveform can change. For time being, I am only considering sine wave only. Okay, so as we can see, the operational amplifier is called as an amplifier because it has the ability to amplify or increase the amplitude of any sine wave from this small scenario to such a large extent. Furthermore, it is also said that it has the ability to change the polarity of the signal. How this can be changed? For example, I can give this small signal to the operational amplifier. It results into an amplified signal, as I can see here, but at the same time I can also see that the phase of the output wave has changed. It means that when I am providing the positive signal at the input, it is giving me a negative amplified signal at the output. When I am providing negative signal at the output, negative signal at the input, it is providing me positive amplified version at the output. This means that the circuitry of the op-amp which was present over here is not only amplifying the input signal, it is also inverting the polarity of the input waveform. So we can say that the operational amplifier can help us to increase the amplitude of the input waveform, as well as it helps us to change the polarity of the input waveform. Okay, how it does these things we will be studying in detail in forthcoming slides. Operational amplifiers are used in the design of oscillator circuits. Please note that we will not be going into the detail of what oscillator circuits are, but of course we should know just a bit about them, that these are those circuits which take only DC input while they generate constant frequency sine waves at the output. Oscillator circuits are actually meant to generate constant sine waves or constant frequency sine waves at their output. They are used in clocks, they are used in computers and so on. We will be asking you about the uses of op-amp, like they are used in the design of oscillators, but these details hopefully will not be asked, that what are oscillators. However, you should know a bit that what oscillators are. Okay, similarly you will be asked about the uses of op-amps, in a sense that they are used in the design of instrumentation circuits, but what are instrumentation circuits will not be asked. However, you should know that circuits like which help us to measure different parameters from human body, like ECG machines and ultrasound, etc., are called as instrumentation circuits, and operational amplifiers are used in the manufacture of these circuits and so on. Okay, operational amplifiers are also used in the design of filter circuits. Again, we do not need to know the details behind what are filter circuits, but we should know what actually filter circuits are. Circuits which have the capability to allow certain frequencies to pass through them while they block other frequencies. For example, if I take the example of this figure, you can see that this is a frequency diagram along the x-axis. From 0 to 10 kilohertz, the circuit will be able to pass the frequency from 0 to 10 kilohertz, but any signal above 10 kilohertz will not be able to pass through the circuit. Similarly, I have taken another example that in this type of filter circuits, In this type of filter circuit, all the signals below 20 kilohertz will be nullified, will be suppressed to zero. However, all signals equivalent to 20 kilohertz and above 20 kilohertz will be able to pass through the circuit. So this case where starting from 0 to some value the circuit is able to pass the frequencies is called as a low pass filter, because it has the ability to pass smaller signals starting from 0 to 10 kilohertz. In this case, the filter does not have the ability to pass the low frequency signals, but it is passing the frequency from 20 kilohertz and above. This filter circuit will be called as a high pass filter. Now you see, this is another filter which does not allow frequencies from 0 to below 30 kilohertz to pass through. Similarly, it does not allow frequencies above 50 kilohertz to pass through. It allows only a band of frequencies from 30 kilohertz to 50 kilohertz to pass through. Such a filter which allows only a band of frequencies to pass through is called as a band pass filter. Now we very clearly know that when we are receiving any signal at our device, but we want to find out or we want to extract out only our relevant signal, we use a filter. Suppose if I am receiving frequencies from 1 kilohertz to 2 kilohertz, but I want to receive only the 1.5 kilohertz channel, it means that I have to place a filter that allows only the 1.5 kilohertz signal to pass through while suppressing all the signals above and below it, right? An example of this can be your old your radio devices, because in radio devices we actually select our specific channel or of FM, for example, and then how do we select it, or how does our device select the specific channel, is because it has filters inside. When we go to that channel, our device suppresses all the other signals but only passes the signals of that specific frequency, and then we can easily hear that frequency. So what we see that operational amplifier circuits are also used in the design of filter designing or filter circuits. Okay, operational amplifier is available in the market in the form of an IC. This is the picture shown over here. What we do, we place the U portion on the top side, which indicates that the operational amplifier is placed in the right position. We start the counting of the pin from this side. Usually we count it from 0, 1, 2, 3, 4, 5, 6, 7. Usually this is the counting convention, but in some books they also count like 1, 2, 3, 4, 5, 6, 7, 8, depends from book to book. However, whenever you purchase any IC from the market, you can see its data sheet from the internet. On every IC, the serial number is written on the IC. Whenever you put that serial number on Google, the detailed sheet of that IC gets opened and you can see its diagram inside and the pin number details. Okay, as such, at this instance of time in our theory course, none of the details of the IC are required right now. I'm just telling for your information that when you will be doing the practical work of OpAmp, you will be coming across this IC, and it will be having some pins, and for which the details you can obtain using the serial number of the IC or the model number of the IC through Google. Okay, now in general, the second pin is the positive pin. The second pin is the negative pin. The third pin is the positive pin of the OpAmp. This pin is representing the negative supply to the operational amplifier. This pin represents the output terminal. This pin represents the positive supply. ठीक है, तो आपको पता ये चल गया कि ये दोनों आपके जो है वो पॉजिटिव नेगेटिव इनपुट को शो कर रहे हैं, ये वाले आपके आउटपुट को शो करिए। ये वाली पॉजिटिव सप्लाई हो गई, ये वाली नेगेटिव सप्लाई हो गई, ये और ये कुछ ऑफसेट नल वगैरह की चीज़ें हैं। वी आर नॉट गोइंग इनटू दैट डिटेल राइट नाउ। इनको अनकनेक्टेड छोड़ने से भी आपके पास बहुत क्लियरली और इजीली आंसर आ जाता है, इससे कोई फ़र्क नहीं पड़ता। बट एट दिस इंस्टेंस ऑफ टाइम यू ओनली शुड नो दैट OpAmp is available in market in an IC form. Not even you are required to learn the pin numbers right now, but it may be required for your practical work. Okay, now we are going to study the working of operational amplifier. The working will be single-handed input based, and it will also be double-handed input based. We will be studying both the cases. First of all, let's see this type. In case of single-handed input, what we do, we ground any one of the OpAmp terminal and we apply the signal on the leftover input terminal. On the basis of this, there will be two cases for applying the input. For example, let us see it in the next slide. Now we can see that in this type of operational amplifiers working, the negative terminal is grounded while the signal is applied to the positive terminal. The second case is when the positive terminal is grounded and the input signal is applied to the negative terminal of OpAmp. One more thing that we all should know before going into the operation of operational amplifier is that the positive terminal of OpAmp is called as the non-inverting input terminal. This means that any signal applied to the positive terminal of operational amplifier will only be amplified and its polarity will not be inverted, whereas the negative terminal of OpAmp is considered as the inverting input. It means that any signal applied to the negative terminal of OpAmp will not only be amplified but also be inverted at the output. Based on this, now let us see the operation. You can see the negative is grounded, the positive terminal has the supply connected. When we apply any input to the positive terminal of OpAmp, what happens is it only amplifies the signal, as I told you, and it does not invert the polarity. Like when the input is positive, the output is an amplified version of the positive waveform. When the input is negative, the output is an amplified version of the negative waveform. So we see that any signal applied to the positive terminal of OpAmp will only be amplified and not inverted. Now see this. Whenever the signal is applied to the negative terminal of OpAmp, it will not only be amplified but it will also be inverted, as is very clear from this diagram that the positive input results in a negative wave at the output, which is also amplified, and a negative wave at the input results in a positive wave at the output, which is amplified. So this gives us single-handed operation that we can keep one of the input terminal as grounded and we can apply any type of waveform on the positive or the negative terminal of the OpAmp. This is actually called as the single-handed operation. Now let us see the other type of working. In case of operational amplifier, it is not necessary to always apply a ground on one of the input terminal and then apply the signal on the other terminal. What else we can do is we can apply a signal between both the terminals of operational amplifier. This will give us an amplified output when we have a differential input. How? Let us see in the next slide. In case of differential input, as I told you, there is the possibility to apply the signal between both the terminals of OpAmp. Now you see there is no ground here at the input terminal, at any of the input terminal, but we can see that the supply's positive terminal is connected to the positive terminal of the OpAmp and other terminal of the supply is connected to the negative terminal of the OpAmp. In this way, a supply is connected between the input terminals of OpAmp. Now the thing is, what kind of supply will be this? In your experiment session, in your practical session, you will be studying about different instruments, in which one of the instrument will be called as a function generator. A function generator is a device which has the ability to generate sine wave, triangular wave, square wave of different frequencies, and that function generator has two terminals. So if I connect the positive terminal of function generator over here and I connect the negative terminal of the function generator over here, this will create a differential or a double-ended operation for the operational amplifier. Now, since I said that the supply or the function generator will be giving us a sine wave at the output, therefore I have drawn this sine wave showing the positive peak at Vd and the negative peak at minus Vd. Now you see what will happen. This is something interesting and something new that all of you should know. Whenever we connect any supply between the terminals, like I haven't grounded any terminal, I have connected the supply between the positive and the negative terminal. So what will happen? Let us see this partially one by one by first considering the positive wave. Whenever the positive wave will be coming, the supply will automatically send half of the wave towards the positive terminal, and the supply will automatically send other negative half to the नेगेटिव टर्मिनल. यानी कि इनपुट की ये जो पॉजिटिव पीक है, जब ये सप्लाई के अंदर सप्लाई से प्रोड्यूस होके इन दोनों टर्मिनल को मिल रही होगी, तो ऐसा नहीं होगा कि पॉजिटिव इसको भी मिल रहा है और पॉजिटिव इसको भी मिल रहा है. नहीं, इस पॉजिटिव सप्लाई के आने के नतीजे में ऊपर वाले पे इसी की आधी वेव जारी होगी, पॉजिटिव में ही जारी होगी, लेकिन नीचे वाले पे इसकी खुद बखुद से इन्वर्ट होके जारी होगी और आधी जारी होगी. जिसके नतीजे में होगा क्या कि जब हम इस वाले का और इस वाले का डिफरेंस लेंगे, हाफ वीडी माइनस, ये तो पहले से माइनस था, माइनस हाफ वीडी, तो टोटल वेव जो इनपुट जारी होगी सर्किट के अंदर वो वीडी होगी, जो मुझे पता चल रहा है कि पॉजिटिव पीक है. तो जो मैक्सिमम वैल्यू इनपुट पर जारी होगी वो क्या होगी? प्लस वीडी. अभी मैं पॉजिटिव, आई एम टॉकिंग अबाउट द पॉजिटिव वेव राइट नाउ. व्हेनेवर दिस function generator will be sending the positive wave inside the operational amplifier, we do not have to do anything. It will automatically be breaking this positive peak into these smaller parts. एक को प्लस हाफ वीडी में तोड़ देगा, इसको एक को माइनस हाफ वीडी में तोड़ देगा. जब हम इन दोनों का डिफरेंस लेंगे तो हमें पता चलेगा जो नेट सिग्नल सर्किट के अंदर जा रहा है वो प्लस वीडी ही जा रहा है, जो कि पॉजिटिव साइकिल में जाना चाहिए. नाउ व्हाट विल हैपन? बिकॉज ऑफ दिस पॉजिटिव सिग्नल applied to the positive terminal, we will get an amplified wave at the output with the same polarity as was applied to the input. Now because of the application of this wave at the output, what we will get? First of all, try to note कि this is inverted in polarity and it is now being applied to the negative terminal. What will happen? The negative terminal will not only amplify this signal but it will also invert the polarity. तो हुआ क्या कि ये जो नेगेटिव मैंने नेगेटिव टर्मिनल पे अप्लाई किया था, ना सिर्फ ये एम्पलीफाई होके मुझे मिला बट इट ऑल्सो गॉट इन्वर्टेड. देखें यहाँ पे ये नेगेटिव पोलैरिटी बताया, यहाँ ये पॉजिटिव पोलैरिटी में आ गया. नाउ बिकॉज ऑफ दिस द आउटपुट इज दिस. Now because of this part, because of this portion, the output is this. At the output I will get the sum of these and the resultant output will be a much amplified wave. Now I can see that when I am applying a differential input or an input between the two terminals of the op-amp, I am getting an amplified positive wave at the output. Now other case for the differential input will be the negative wave applied. Now let us see how will it work. Okay, now we can see that we are again considering the previous circuit and we are in continuation of the last circuit, and we have applied the input signal between the terminals of the op-amp. Okay, and now we are talking about the negative peak that is actually generated by this function generator or the AC supply. When this AC supply will be generating the negative peak, what will be happening automatically? It will automatically be giving this thing to the positive terminal and it will automatically be giving this input to the negative terminal. यानी आपने मैंने कुछ भी नहीं करना. जब कभी भी मैं फंक्शन जनरेटर को पॉजिटिव और नेगेटिव टर्मिनल के दरमियान इस तरीके से कनेक्ट करूंगी, वो ऑटोमेटिकली ये करेगा कि जब उसकी नेगेटिव पीक आया करेगी, खुद ब खुद से उसका -हाफ वाली चीज पॉजिटिव पे भेज दिया करेगा और उसकी पॉजिटिव हाफ वाली चीज नेगेटिव टर्मिनल पे भेज दिया करेगा. उससे होगा क्या कि ये वाला सिग्नल देखिए यहाँ लिखा हुआ है -हाफ ऑफ ईडी, इसका फिर से डिफरेंस निकालेंगे माइनस ऑफ दिस सिग्नल, ये रहा. तो इसका नेट आंसर क्या आएगा? -VD, यानी कि टोटल मिला के जो इनपुट सर्किट के अंदर जा रहा है दैट इज -VD. दैट कैन बी इजीली वेरीफाइड यूजिंग दिस इक्वेशन. Now what will happen and how the op-amp will respond to this negative waveform? इसके अप्लाई करने की वजह से positive terminal does not have the ability to invert the signal, it only amplifies the signal. So what I see here the output is कि ये वाली चीज मुझे directly amplify होके मिली without any change in the polarity. At the same time, this part when applied to the negative terminal not only got amplified but it also got inverted. At the output terminal, both of these will be added with each other and it will result in a negative waveform at the output with much higher amplification. So what we see is when we apply any signal between the op-amp terminals, it gives us amplified output. Application of input signal between the op-amp terminals is called as the differential operation. Now let us see other type of double-ended input that can be applied to the operational amplifier. The other type of double-ended input is called as the common mode operation. Please look at this circuit. You can easily see that both the positive and negative terminals have been tied together and connected to a single AC source. Again, this AC source can be the function generator that I talked about in the previous slide. What will happen when application of voltage at the input terminals of op-amp in this scenario will give similar inputs to both the terminals of op-amp. For example, if the positive peak is coming, positive peak will be going to the positive and negative terminal. Now what will happen? The positive terminal will be amplifying this input without changing the polarity. The negative terminal will be amplifying the input but also inverting the polarity. At the output, both of them will be added and the result will be 0. One thing which is I can call it a mistake, is that I forgot to draw this as an amplified version. Both of them are exactly looking similar, but let us assume कि ये यहाँ पे जो कुछ भी आ रहा है वो इनपुट के मुकाबले में एम्पलीफाइड है. ये इत्तेफाकन दोनों सेम साइज के बन गए. एनीवेज, द end result will be both these will be in opposite polarity with respect to each other, and they will cancel out, resulting in a 0 volt output. What I see from this operation is whenever similar input signals are applied to the input terminal of OpAmp, they eventually result in a 0 voltage at the output. Here I talked about the positive peak. Now let us also check the negative peak. Let us go to the next slide. Now you see here again the circuit is the same. This is the supply, but from the supply the negative peak is basically coming as the input. What will happen? The positive peak will amplify it without changing the polarity. The negative terminal will not only amplify, but it will also invert the polarity. Again, they both will be added at the output terminal, resulting in 0 volts at the output. So with these two examples, we are now sure that whenever we have common mode operation at the input terminals of OpAmp, they eventually result in a 0 voltage terminal, a 0 voltage at the output of the OpAmp. This concept will be used to discuss the behavior of noise, the unwanted signal, and how the OpAmp responds to it in the forthcoming slides. Please try to understand this concept very clearly. So after studying the single-ended and the double-ended operation of the OpAmp, now we can see that both types of operation are possible, single-ended as well as double-ended. In case of double-ended operation, when the inputs were differential, where the inputs were applied between the OpAmp terminals, the OpAmp produced the output. I am talking about the second case, the double-ended differential input. उसमें हमने देखा कि जब दोनों टर्मिनल्स के बीच में सप्लाई लगाई गई तो उससे आउटपुट प्रोड्यूस हुआ. बट इन द थर्ड केस, द double-ended common mode input, when we applied similar signals to the OpAmp terminals, they in each case resulted in a 0 volt output. So what we can say is that the operational amplifier actually amplifies the difference of the input signal or the differential input signals. However, it actually nullifies the common input signals. दोबारा से बता रही हूँ, go back to the double-ended operation जिसमें कि differential था. जब दोनों के बीच में आपने अप्लाई किया तो क्या हुआ? तो आउटपुट पे कुछ ना कुछ जनरेट हो गया, ठीक है. लेकिन जब आपने दोनों इनपुट्स के ऊपर सेम चीज अप्लाई की, मैं कॉमन मोड की बात कर रही हूँ, तो उस केस में आउटपुट पे 0 आ गया. तो हम ये कह सकते हैं कि ऑपरेशनल एम्पलीफायर रिस्पॉन्ड करता है या बेसिकली आउटपुट प्रोड्यूस करता है उस वक्त जब हम सिग्नल दोनों टर्मिनल्स के दरमियान अप्लाई करें, डिफरेंशियली अप्लाई करें, और ये नलिफाई कर देता है, 0 कर देता है ऐसे सिग्नल्स को जो कि इसके दोनों टर्मिनल्स के ऊपर बराबर हों, जो कि कॉमन मोड इनपुट में हुआ, ठीक है. वी विल बी यूजिंग दिस कॉन्सेप्ट इन द forthcoming slides. Now let us टॉक अबाउट नॉइज इम्यूनिटी एंड कॉमन मोड रिजेक्शन। देखें, जितनी एनालिसिस अभी जो हमने ऑपरेशन ऑफ एम्प का पहले पढ़ा है उससे पता ये चल रहा है कि इनपुट टर्मिनल पे अगर सेम तरह की चीज पहुंच जाती है तो वो खुद ब खुद से अपोजिट हो जाती है आउटपुट पे और कैंसिल हो जाती है, नलिफाई हो जाती है। नाउ वी टॉक अबाउट नॉइज। फर्स्ट ऑफ ऑल, try to observe that ऑपरेशनल एम्पलीफायर इज अवेलेबल इन द फॉर्म ऑफ आईसी। ये हम ऑलरेडी डिस्कस कर चुके हैं। मैंने ये भी बताया था कि दोनों इनपुट टर्मिनल्स आईसी पे एक दूसरे के बिल्कुल बराबर में होते हैं। तो कोई भी अनवांटेड सिग्नल, जिसको कि मैं कहती हूँ नॉइज, अगर एक इनपुट टर्मिनल पे पहुंचेगी तो बिल्कुल वैसी ही दूसरे इनपुट टर्मिनल पे भी पहुंचेगी, बिकॉज दे आर वेरी क्लोज टू ईच अदर, दे आर बाय द साइड ऑफ ईच अदर। ठीक है, दे आर बिसाइड ईच अदर। इसका मतलब ये है कि अगर मेरा ऑपैम्प कोई अनवांटेड सिग्नल जो कि नॉइज कहलाता है वो कहीं से भी पिक कर लेता है, तो चूंकि आईसी के अंदर दोनों टर्मिनल्स एक दूसरे के करीब हैं, तो वो अनवांटेड सिग्नल अगर पॉजिटिव टर्मिनल पे आ रहा होगा तो एग्जैक्टली वही अनवांटेड सिग्नल नेगेटिव टर्मिनल पे भी आ रहा होगा। इससे होगा क्या, पॉजिटिव टर्मिनल उसको सेम पोलैरिटी के साथ एम्पलीफाई करके आउटपुट पे भेजेगा, नेगेटिव टर्मिनल उसको इनवर्ट पोलैरिटी के साथ एम्पलीफाई करके आउटपुट पे भेजेगा, और वो नॉइज का इफेक्ट खुद ब खुद से क्या होगा, जीरो हो जाएगा। तो कहने का मकसद ये है कि हम अज्यूम ये करते हैं कि ऑपरेशनल एम्पलीफायर के दोनों इनपुट टर्मिनल्स पर जो नॉइज आएगी, जो अनवांटेड सिग्नल अगर गलती से कैच होगा तो वो हमेशा सेम नेचर का होगा और वो खुद ब खुद से एक दूसरे की इनवर्ट पोलैरिटी में एम्पलीफाई होकर जब आउटपुट पे पहुंचेगा तो खुद ब खुद से कैंसिल आउट कर देगा, एक दूसरे को नलिफाई कर देगा। तो हमारे नॉर्मल ऑपरेशन के दौरान अगर हमारे अपने नॉर्मल सर्किट का ऑपरेशन चल रहा है, हमारा सर्किट अगर नॉइज को कैच कर भी रहा होगा तो वो अंदर ही अंदर जो आउटपुट पे एक दूसरे को इन्वर्ट करके भेजता है वो खुद ब खुद से कैंसिल आउट भी हो रहा होगा। मुझे अपने आउटपुट टर्मिनल के ऊपर एक्चुअल सिग्नल के अलावा कुछ और नजर नहीं आ रहा होगा। क्यों नहीं नजर आ रहा होगा, मैं वही बता रही हूँ कि अगर हमारा ऑपैम्प आसपास का कोई नॉइज कैच कर भी रहा होगा तो आउटपुट पे मुझे सपोज करें ट्रायंगुलर वेव दिखनी है, वो बिल्कुल प्योर ट्रायंगुलर वेव दिखेगी। क्यों? क्योंकि दोनों इनपुट टर्मिनल्स ने जो नॉइज कैच की वो आउटपुट पे आके एक दूसरे के बिल्कुल अपोजिट थी, वो कैंसिल होकर खत्म हो गई। मुझे आउटपुट पे जो ट्रायंगुलर वेव साफ सुथरी दिखनी थी, क्लियर दिख रही है। ये ऑपरेशनल एम्पलीफायर का फीचर कि वो अपने इनपुट के ऊपर हर कॉमन सिग्नल को आउटपुट पर भेजकर जीरो कर देता है। दिस फीचर ऑफ ऑपैम्प इज कॉल्ड एज कॉमन मोड रिजेक्शन। लेट मी रिपीट दैट। मैंने ये पहले ही देख लिया है कि जब ऑपैम्प के इनपुट के ऊपर कॉमन सिग्नल दूं, इट विल बी नलिफाइड एट द आउटपुट, क्योंकि वो अपोजिट होते हैं। तो हम चूंकि ये कह रहे हैं कि नॉइज हमेशा दोनों इनपुट टर्मिनल्स पे सेम आएगी, ये एक हमारी अजम्पशन है, ठीक है, कि नॉइज हमेशा इनपुट टर्मिनल पे सेम आएगी। तो इस वजह से नॉइज जब कभी भी आउटपुट पे पहुंचेगी वो आउटपुट को खराब नहीं कर पाएगी, क्योंकि वो खुद ब खुद से नलिफाई हो चुकी होगी। दिस फीचर ऑफ ऑपैम्प टू नलिफाई the common signal or to nullify the common noise at the input terminals and at the output terminals is called as the common mode rejection feature of the operational amplifier. Now we will be studying few terminologies of the op-amp. We should at this time be aware of the fact that differential input is represented by the symbol VD, and it is the difference of the signal between the input terminal number 1 and input terminal number 2, whereas Vi1 will be the signal on the positive terminal and Vi2 will be the signal on the negative terminal। यानी Vi1 और Vi2 के दरमियान का जो डिफरेंस सिग्नल कहलाता है वो VD कहलाता है। We can also define a common input signal for the op-amp। ठीक है, बेसिकली दोनों इनपुट टर्मिनल्स के ऊपर आप जो भी सिग्नल अप्लाई कर रहे हैं उसका एवरेज कर देने से जो भी सिग्नल हासिल हो रहा है वो कॉमन इनपुट कहलाता है। ठीक है, Vi1 पॉजिटिव टर्मिनल का सिग्नल है, Vi2 is the signal of the negative terminal. When we take the average of both of these, what we get the signal which is common to both of the inputs. अब Vi1 और Vi2 सेम थे या नहीं थे, इस बात का हम इस वक्त कोई जिक्र नहीं करें, बस कहा यह जा रहा है कि इन दोनों के सिग्नल का जब कभी भी एवरेज निकाला जाएगा, the thing or the signal that we get will be called as the common input. Okay, now we are going to find the output voltage and voltage gain for the operational amplifier. But before we find these parameters for the op-amp, let us consider a general circuit. Consider this circuit. We are giving an input value of 2 and it is giving us an output value of 20. I can very clearly see that this circuit has some amplifying behavior because it is converting an input signal of 2 to an output signal value of 20. Can I find how much gain it is providing to my input signal? Yes. If I divide the output by the input value, I can clearly find how much gain or amplification is provided by the circuit. So in general, now we know that if we want to find the gain of any type of circuit, what we can do, we can simply divide the output value by the input value, and resultingly we can see how much gain is being provided by the circuit. Now please note that the gain is usually represented by the term A. The output voltage is represented by V0, the input voltage is represented by Vi. If I am giving the input signal as Vd, then this equation of gain can be modified to this equation. For example, we discussed earlier that we can apply two types of inputs. We can apply the differential input, we can apply the common mode input. Suppose if I am saying that I am applying the differential input, then instead of Vi, I can write it as Vd because I am applying the differential input. So if the input is differential, I would say that its gain will also be differential and can be represented as Ad. From this I can find a value for V0 equal to VdAd. Now if I say that the input that I am applying is not differential but it is common signal, it can be represented as Vc. So this equation can now be written as V0 over Vc, where Vc is representing the input signal. A common mode अगर input signal पे दे रही हूँ, then the corresponding gain will be called as the common mode gain represented by AC. I can again find out the value of V0 from this expression. Now please note that I have obtained this value of V0 and this expression of V0 for the op-amp when the input is differential and when the input is common. Please note that the operational amplifier has the capability to give us this output and it also has the capability to give us this output. So the total output signal for any op-amp will be the sum of this V0 and will be the sum of this V0, because operational amplifier has the ability to not only process the differential signal but it also has the capability to process the common signal. No doubt it is giving a 0 at the common signal, but it is processing it, that is why it is giving us a 0, right? So the sum of both these expressions of V0 will be giving us the total value of the output voltage. Let us see that. The total output voltage can now be represented as the sum of VD-AD plus VC and AC. We will be continuing this lecture again in the we will be continuing this topic again in the next lecture.